Compressing many similar big files. I have hundreds of similar big files, 30 megabyte each, which I want to compress. Every pair of files have 99% of same data, less than 1% difference, so I expect to have not more than 40 to 50 megabyte archive. Single file can be compressed from 30 MB to 13 to 15 MB, with XZ-1, GZ-1, ZIP2-1, but when compressing 2 or more files I want to have archive with size 13-15 MB plus N0.3 MB, where N is number of files. When using tar to create solid archive, and XZ-6 to define compression dictionary to be bigger than one file, update, this was not enough, I still have archive with size N13 MB. I think that both ZIP and ZIP2 will not help me because they have dictionary less than 1 MB, and my tar stream has repetitions every 30 MB. How can I archive the my problem in modern Linux using standard tools? Is it possible to tune XZ to compress fast, but use dictionary bigger than 30 to 60 MB? Update. Did the trick with tar-c input underscore directory, xz-ma2 equals dict equals 128 meters, mode equals fast, mf equals hc4 memory equals 2 grams and gt, compress.tar.xz. Not sure about necessary of mf equals hc4 and memory equals 2 grams options, but dict equals 128 meters set the dictionary to be big enough, bigger than one file, and mode equals fast make the process bit faster than E.
Given your details, I assume that you have verified that your files really have 99% of data in common, with a contiguous, or almost contiguous 1% of difference in them. First, you should use tar to make one archive with your files inside it. For tests, I would create a tar with 10 files, so having a 300 MB size. Then, using XZ, you have to set it so that the dictionary is bigger than the size of one file. Since you don't say if you have memory restrictions, I'd go with XZ-9. There's no point in not using all available memory. I'd also use the extreme preset to test if it makes difference. Dictionary size. In one documentation that I have available, site, it said that the dictionary size is roughly equal to the decompressor memory usage. And the -1 parameter means addictive. 1 MB, -6 means 10 MB, or 8 MB in another part of the same manual. That's why you're not getting any advantage by tarring those files together. Using the -9 would make the decompressor, and, so, dictionary, be 64 MB, and I think that is what you wanted. Edit. Another possibility would be using another compressor. I'd go with 7-zip, but would tar those files first and then 7-zip them. Depending on your file's content, perhaps you could use 7-zip with ppmd method, instead of LSMA or LSMA2. That is the default and the same used by XZ. Not good. Zip, dict equals 32 kilobits. Zip, dict equals 900 kilobits.
If they are truly 99% similar as you say, you should be able to use BSDIF or a similar algorithm to calculate differences between the files. Is the difference cumulative, i.e., each file differs a little more from the first, or is the difference between any two files pretty much the same? If it's not cumulative, you should be able to take any arbitrary file as the baseline. Run BSDIF comparing the baseline file to each additional file. Store each diff as a separate file, alongside the baseline file. Run a compressor like XZ across the results, the baseline plus the diffs. The result should be much smaller than just zing the entire archive. You can then reconstitute the original files by applying the diff on top of the baseline to get each of the other files out.
U, I, may use tar with some archiver capable of long-range pattern detection, for example, RZIP or LRZIP, README. Both uses long-range redundancy detection/deduplication, then RZIP uses BZIP2 and LRZIP uses XZILSMA/SPAC. RZIP is a compression program, similar in functionality to XZIP or BZIP2, but able to take advantage long-distance redundancies in files, which can sometimes allow RZIP to produce much better compression ratios than other programs. The principal advantage of RZIP is that it has an effective history buffer of 900 MB. This means it can find matching pieces of the input file over huge distances compared to other commonly used compression programs. The XZIP program by comparison uses a history buffer of 32 kilobytes and BZIP2 uses a history buffer of 900 kilobytes. LRZIP have larger buffer and may use many compression algorithms, very fast, good, and one of the best, SPAC, after deduplication. LRZIP uses an extended version of RZIP which does a first-pass long-distance redundancy reduction. The LRZIP modifications make it scale according to memory size. The data is then either 1. Compressed by LSMA, default, which gives excellent compression at approximately twice the speed of BZIP2 compression. Other way is using BUP, backup program with block/segment level deduplication, based on Git pack file. It uses a rolling checksum algorithm, similar to rsync, to split large files into chunks.